logic circuit for a first failure annunciator. Show the schematic of the first failure annunciator. The first failure annunciator is a circuit that tells the system operate which input device save the warning signal that causes the system to shut down by the way of background. Many industrial systems have input device which constantly monitor condition in the system, making sure no unsafe condition exists. If an unsafe condition should occur, this device should be system down to eliminate the dangerous condition to below the horn to inform the operator. This is the purpose of first failure annunciator. Yung first failure annunciator is a circuit na nag-ooperate para magkaroon ng warning signal kung ang system ay mag-shutdown. As specific to have in mind, consider an industrial air gas heat furnace. 3 unsafe conditions which could possibly occur such a system are that the natural gas supply pressure too high, the combination air pressure is too low to a quantity burn all the gas, and the temperature has extended the maximum safe value of the particular furnace. The maximum safe temperature is commonly called the temperature high limit or just the high limit. Alin man dyan sa tatlo ay kinikonsider na unsafe enough. Pag pinag-shutdown ang system, yung gas pressure niya ay temperaturang babalik sa normal. Kaya dahil doon, naging kailangan ang first failure annunciator. Any of the condition is unsafe to warrant immediately shutdown of the unphased. The gas pressure may have temporary surge up and then return to normal. Therefore, a first failure annunciator is needed. Is to be understood the figures 1 to 16 does not show a full circuit which fails the furnace is shut down. This is only the first failure annunciator circuit. The high gas pressure which open because the gas pressure is below the set point to press sure switch. The low air pressure switch open because the air pressure is open because the pressure below is the set points to the pressure switch which air pressure is above the set point of the pressure switch. Now consider the non-5. It's number 1 input and also high due to the action of the reset line at some time in the past. Therefore, the output of 12 went LO, applying an LO to input 1 and non-4. This is the diagram. Dialog outline. The transistor switch decision maker. Agreement should be applied to NAND 6 and NAND 7 and also to NAND and NAND 9. Therefore, NAND 6 and 8 have high output and NAND 7 and 9 have low output. Since all the input amplifier to LO input from NAND designed since the input amplifier the NAND, and therefore the also in tracking lamp turn of NAND 10 has all input high from NAND 4 and 6 and 8. Its input therefore LO, causing the LO to OA. The horn is diagnosed to has high output when he applied to the number 1 of NAND and 1 and 2. There is complete situation under the normal condition. Now, suppose to the failure is the pressure is too high. It is cause high voltage input to SCI which deliver the logic high to input 2 and NAND 1. now 2 is into NAND 1, so it output goes LO and causes an LO input to 2 of NANDs, which drives the output of NANDs HL. Therefore OA1 has a high input and turns into high pressure lamp. The output goes LO because the number in input of NAND 4 has already high. The LO from NAND 4 feedback ground to input of NAND switch seal the NAND's output high. The only way to break the seal is pushing the reset on the driving the number 1 input of NAND 4 LO. When have seen how NAND 4 and NAND 5 sealed up and how they turn the proper indicating light. Meanwhile, 2 outputs goes to LO and apply the LO input 1. The NANDs 1 and 2 and 3 even make the high pressure switch return to the open condition. The high gas pressure indicating lamps will continue glow because of the seal of the NAND 4 and NAND 5 combination. Alin man dyan ay kaya ay pressure naman, alin man din dun kaya ang pressure naman ay nasa high. Yung decision maker, yun yung dapat yung pressure naman ay high para ma-open yung pressure switch.
Ang topic ko ay part ng the transistor switch as a decision maker. Umpisahan ko na. The output gets low because the number 1 input of 94 was already high. The low from the 90 feedback around the 2 input. One of NANDs which seal the NAND's output high. The only way to break this seal is by pushing the reset button and driving the number 1 input of 94 low. We have seen how 94 and 95 cell up and how they turn on the proper indicating light. Meanwhile, the 2 output of gas low and applies a low to input 1 and 1, 2, and 3. Even if the high gas pressure switch return to the open condition, the high gas pressure indicating lamp will continue to glow because of the cell of the 94-95 combination. The foregoing explanation was based on gas pressure being the first player, but of course the circuit action would be the same if the air pressure or temperature high limit was the first player. Air pressure player would seal up the 96-97 combination and lock 90 and 93 and starting condition with output. High temperature limit player would seal up the 99 combination and lock 91 and 2 output high when the lockout line went low. So, balik po tayo dun sa una. Dito daw, ang output dito sa low ay dahil ang number 1 sa output ng 94 ay na high, na ang low mula sa 94 ay bumabalik sa input 1 ng this. Nagsisell sa NAND's output high. Ang tanging paraan upang masira ang selyo na ito ay pamamagitan ng pagpindot sa i-reset, ngunit tunilada at paghihimok ng number 1 sa input 1 ng 94 low. Nakikita natin kung paano ito nagsisell up ng 94 at 95 at kung paano nila ino-on ang tamang indikasyon. Samantalang ang output ng 2 ay napunta sa low at naglalapat ng low sa input 1 ng nandis 1, 2, and 3 kahit na bumalik sa bukas na kondisyon ang switch as ng mataas na presyo ng gas. Magpapatuloy na kumikinang ang lampara na nagpapahiwatig ng mataas na presyon ng gas dahil sa selyo ng mga kombinasyon ng 94 and 95. Ang pagkapigo at paglimitasyon sa temperatura na ay magsasell up sa kombinasyon ng 99 at mailak ang 91 and 2 out na maglalagay ng high kapag ang lockout line ay napunta sa low. Next is logic circuit for machine tool drilling cycle. Show a root drawing of a drilling apparatus. The workpiece is brought into position and held steady by lamp. 2 holes are to be drilling in the piece. 1 hole is vertical, 1 hole is horizontal, and both must pass through the same internal point. Therefore, they cannot both be drilling at the same time. The logic circuit implement the following cycle. So, dito daw ang ito na, diba ito ay yung box, nagpapakita ng magaspang na pagguhit ng isang drilling apparatus. Ang workpiece ay dinadala sa posisyon at pinipigilan ng mga lamp. Dalawang butas ang dapat i-drill sa piraso. Ang isang butas ay patayo, ang isang butas naman ay pahalang, at ang dalawa ay dapat dumaan sa parehong panloob na punto. Sa makatuwid, hindi sila maaaring mag-drill sa parehong oras. Ang logic circuit ay nagpapatupad ng sumusunod na cycle. Then next, ito naman ang sa cylinder. Dito naman meron push button. Kapag pinush natin yung magsusupply, yun, magsusupply na ang control para mapagana ang dalawang solenoid at cylinder. At para natin mapagana ang cylinder sa control, meron isang interlocking na nasusunod para mag forward at backward ang cylinder. Yun lang po.